Now see, I grew up in Virginia, so the idea that schools would have numbers is really neat to me. That's a real New York thing. So hopefully you don't lose your numbers and end up in the wrong place.
Okay.
You ready to roll?
Yep.
Okay. So my name is Margery Daughtrey, and I work as a plant pathologist. Does anybody have any idea what a plant pathologist is? Okay. Very good. You get an A. All right. That probably means you know somebody who's a pathologist. So there is, let me just wade through here to grab things. There is a whole science that relates to the diseases of plants, and there are tons of books written on it, some of which have neat illustrations. And it's hard for people at first to even realize that plants can get sick too. But you've been hearing about that as you've gone to these talks today. And my job is, first of all, to figure out what the plant is, because I work just with ornamental plants. A lot of the people here work with the farmers who are producing food, and I'm working with the people in the greenhouses and the nurseries, and the people who take care of the trees, the arborists who work out in the landscape taking care of trees. And they will bring me things that look funny. So one of the questions I had when I was in college was sort of to define what could be wrong, how you would know there was something wrong with a plant. So let me ask you that. How would you know that a plant was sick? What would it look like?
The changes of brown.
Change to brown, okay.
It wouldn't grow as much.
It wouldn't grow as much. That's a good one. Anybody else?
It would like tilt to the side.
It could tilt. Yeah, if it's tilted, it doesn't look too good, right?
You
Yeah.
see a change.
A change in anything, really. Okay. Anything looks different. And one of the things to think about is that something we can't do is that a plant can do this. What would you say this plant's doing?
Making peaches.
Giving up.
Giving up is a good word for it. The word I would use for it is that it's wilted, okay? Because,
Why
you
is
know,
it pink?
usually well, the pink is because it's an ornamental plant and they decided to make one that was pink in the center. So it looks pretty, right? But from the plant's point of view, it probably doesn't like being pink because, as you know, the green part's what the plant wants, because that's the part that can make food with the sunlight and the water. So it can do less photosynthesis than a plant that was solid green. But we like the pink, so we make it this way. The plant breeders design it to look like this. But it's not supposed to droop down like this. And when you see a plant that's wilted, what are you supposed to do? Water it, right. And that's usually the right thing to do, because usually somebody forgot to water it. But sometimes the roots of the plant may get sick. And that's what's happened in this case. The roots are actually dark brown in here instead of a nice bright white. And that's easier to tell when you've got a plant in a pot, because you can knock it out of the pot and look at it. But that's a whole nother realm of things that can go wrong besides the things that can happen on the top of a plant.
Doesn't the plant need chloroplasts?
A plant needs
speak up?
chloroplasts, exactly. She was saying, does a plant need chloroplasts?
Oh, okay, thank you.
And the chloroplasts are always in this green section, okay? So the way this leaf is operating is it's working with its green part, and then we're enjoying the red part, okay?
Wait, is the red part pink or something? Isn't it pink?
No, it's natural to the plant. It's just that there are different kinds of pigment. You know, like when you're an artist, you have different colors of pigment that you use to make your paintings. A plant has different kinds of pigment in it too. So over here there is some red, but the green is masking it. There's a red pigment showing here. And a plant actually uses its red pigment for other things. It uses it to defend itself. Those are called anthocyanins, and they're chemicals that are very good for the plant. Yeah.
I have a question.
Uh-huh.
Does the color of the paint, does it affect the growth?
It would probably slow the growth a little bit, okay? So if you had another, we call them cultivars, you know, ones that look a little different. If you had another cultivar of this plant, and it was solid green, it would probably grow faster, yes, okay? And that's because of that ability to make food, you know? So that's all very logical. Good question. So here's another thing that fits with one of the comments you made. Somebody said something about plants not growing as well when they're sick. So here you've got one plant that's normal. This one's got a flower and it's a good size and everything. You know what this one is? Anybody know the name? It's called a begonia, okay? And so here you have one, it's the same kind of plant, but it's got two brown leaves. You mentioned the brown leaves. Brown leaf isn't good for a plant. It wants green leaves. And it's also stunted. It's short. And the flowers sort of look dead on there. So this plant is sick, this plant is healthy. So the grower who had this in his greenhouse brought it to me to ask me what was going on. And so what I have the advantage of, because I have this laboratory, which is great fun. If you can ever grow up and have a laboratory, try to do it. A laboratory is marvelous because then you get to grow out on Petri plates to find out what's inside that plant that made that happen. So we took the stem and cut little sections across it, and we got this fungus to grow in there. I don't know if you get to grow fungus in your labs in school. And this is a particularly interesting fungus. This is one called fusarium. And this fusarium fungus is one of our favorites because it actually looks a little bit purple. You can see it better from the back. So it's colorful. All the different things that can attack a plant and make it sick have their own look. And for many years we used the look of them, both just to the naked eye on a Petri plate and under the microscope, to decide which one was which. And the fancy word for that was we used the morphology of the thing to figure out what it was. And you'd look at the little spores, which are this orange ooze on the top of this plate are masses of spores of that fungus. And you would look at that under the microscope and see how big the spores were. And these actually look like little crescent moons. And they have like 4 or 5 cells on them. This is the fungus fusarium. So that's the old-fashioned way to identify things. But probably in another 20 years, nobody will even do this in a laboratory. Because now we use DNA to decide which thing is which. So if we wanted to, we could send this off to somebody who has that kind of equipment at a university somewhere and pay a lot of money, and they would tell us exactly what the organism was in this Petri plate. And I'm used to doing it the old-fashioned way, where first I grow it, and then I look at the size of the spores and the shape of the spores and figure out what's going on. So there's a big change right now, and everything's changing its names. So what I call this fungus, it might not be called in 10 or 20 years either. But it's quite interesting to me to start with a sick plant and then go inside it, pull out, get something to grow that's inside it that's causing the disease, and then identify it and help the grower learn how to cope with it. But most people don't really look into plants to see what might be going on. They don't even notice there's anything wrong with them. You all walk past this plant on the way in. Whoops. See the spots on there?
Yeah.
Okay, that's an iris. And it's mostly okay, but it has spots.
Will you just cut it?
And those are caused by, I cut it off myself, yeah. And that's a disease for that plant. And I think what you're asking is, wouldn't you fix it if you cut that off, right? And you would. So if you just have house plants at home and one leaf looks funny, then just take it off. That's okay. That's a good way. That's called a physical disease control, when you take something off and put it in the trash. But if you have a giant greenhouse and you have 100,000 of a plant, you might not really have the labor to get that done. It can be really hard. So perhaps you want to instead spray the crop to protect it against the fungus that might attack it or things like that. So I want you to all have a chance to look at a microscope and play with things, and we have to go fast today. So would like you two and the rest of you go over there with Lynn, and she's going to help you isolate a fungus, and the rest of you will probably get a chance to do some of that too. But I have some microscopes back in here set up, and we can take a look at some things. We have bacteria and fungi and all sorts of jazz here. So let me get in here.
Please stay.
Move you around.
Here's how we go about doing a diagnosis. Take your leaf that's got the symptoms on it, brown spots, and take your scissors and cut up pieces that have a green edge and some brown stuff on it too. And drop it into your beaker that has diluted bleach in it. I'll spill it out. 1 part bleach to 9 parts water. Drop it in there and stir it a little.
Are you just taking photographs? I'm thinking they're doing something productive.
Actually, we do know.
I can take a photo.
I can tell what they are when they come in. Yeah.
It's a beautiful tree.
So you have.
Maybe you come back here, you get a better angle.
How about if you two work right here on the Pachysandra, okay? And then somebody else can do the mountain laurel, and you ladies have iris. So if somebody wants to squeeze in the middle, put some little triangle shaped pieces into your beaker.
How are we starting? Okay, so don't open that yet. So then we keep on doing the whole thing?
Yeah.
The whole plant?
Tinier.
So they're cutting pieces of the plant up and putting them in bleach?
diluted bleach, just to surface sterilize, then we'll put it on the petri dish, and in a few days something will grow out of it.
So you're seeing if a fungus is growing on it?
Anything, there's all kinds of stuff in the air, obviously airborne stuff will be on the leaf, but the bleach will clean it out. In a few days the fungus that's inside there will start to come out. And it'll fill up the plate like the one that Marge showed with the like a 5-petaled flower it looks like in the plate.
Yeah.
So that's the part we take and look at under the microscope.
You identify the fungus.
Yeah, cut up.
Get a little piece of green and then we have this, all of this right here. Here, when I cut them, can you just throw them in the bleach?
Put about 5 of them in your plate.
I said, sure, she'll run, she'll jump over something, but it's okay. As long as you got the stuff. When they don't wear proper uniform, they get the biggest, baggiest skirt. You like this skirt? You look so cute. I gotta take a picture. Come here, show them your jeans. Oh, yes, it does.
Oh, wait, so you gave her that skirt?
Oh, no, they gave her the skirt. We always have a big, ugly, baggy skirt. It is a But this is your punishment for not wearing your That's why tomorrow.
The name of your school.
Everyone will.
Okay, name, date.
On here. That's why we
On this?
Yep. Take that with you.
Did you go in there?
We're writing this down, so basically bleaching the brown part.
Excuse me.
We'd be up to our waist in leaves, right? So you need things to be decomposers. So it's helpful. Is everybody getting to see something? I have to make sure that they don't need to be readjusted. It's hard to crouch and see. Do you see spores with that are brown that have a bunch of cells? They look like worms. They look like very fat worms. Yeah. What people are doing over here
What's in there?
is the kind of thing
Are those insects?
No, it's the bacteria from the...
Oh, from...
I can't see it.
So hopefully we'll have a couple to take back to your school.
Yes. I said gave up.
Yep.
The babies are still growing. I mean, they're still new plant,
Right. So for example, if you drench that with a fungicide that helped its root rot, it would be able to keep growing and recover.
Okay, because I have house plant. I never have one.
Yeah.